Hi, everyone. Glad to be here. I think this is actually my first time to Amsterdam. Hope you had a wonderful week and weekend. So I'm going to talk about how to enhance your Web3 applications with our middleware. But before we start the introduction of the middleware, I'd like to go over a few challenges first. So if you are building Web3 and you care about user experience in fairness, in privacy, and maybe in security, you really should just listen about this. So there are actually a few challenges. I will just put them in several different categories, like in DeFi, in DEX, in NFT, in governance, and maybe lastly in security as well. So first, challenges in DEX. There are a bunch of you, but let's start with MEV, or maximum extractable value. I think this is maybe something that you have heard about, but it really is happening everywhere, and it's fundamental to many public chains, because it's just happening due to several reasons, like it doesn't have privacy on the pending transactions, because every single public chain has a place called mempool, and that place will just expose your pending transactions. And that means your transactions are exposed before it's confirmed. Imagine that you are trading on a traditional exchange, and your trading plan, your trading strategy is actually known by other people. This is actually really bad. And second thing is actually about fairness. So on blockchain, there are really some powerful parties that are able to just manipulate the ordering of your transactions with some techniques like gas bidding, or even it's just simply by mining, because all the block producers have the ability to just change the order as they want. That includes miners, that includes validators, and maybe layer 2 sequencers as well. And next thing is gas payment. We know that as of now, the experience of using DEX or DApp is like you have to pay gas fee in native token. So if you trade from token A to token B, but you still have to have the token C, native token, to pay the gas fee. And it's very inconvenient, because for first-time users, it's kind of a very high entry bar for them to start using any of the crypto product, because they will have to fund their wallet with the native token for gas fees. And also, even for frequent traders, it's a headache, because they will always have to allocate some fund in native token so that they can cover the usage on the system. Also, this is something that not many people look at, which is the unlimited approval issue. And it's actually also fundamental to many smart contracts, because in the token standard like ERC20, if you want to list it on exchanges, DEX, you will have to just use this practice of approval. You have to ask user to approve some allowance on the DEX so that they can take your token and then trade into another token for you. But then, for convenience reason, many developers just adopt this practice that they will ask for unlimited approval, which brings the issue or concern that if something happens to the smart contract, the attacker can just drain your fund. And that actually happened before. During some of the smart contract hacks, everyone is panic actually, was panic about how to revoke their access on those smart contracts. And every time if that happens, there will be congestions as well, because everyone is just about going into the chain and trying to revoke the transaction, the approvals. And then let's switch to another category of challenges in NFT. So this is also something new, but the concept is same. It's just also about MEV, because this actually introduced some unfairness into the system, because there are also powerful users trying to sniping the NFTs, those very rare ones with front-running ability. So not only the front runners, but maybe miners are doing that themselves. Also, this metadata exploiting is very serious, because for NFT, what matters is just metadata. It represents the value of the NFT. And usually, it comes with several different attributes or properties. But for some project, when they're launching the NFT, what they do is they can maybe, they choose to not review it first. But then when they review it, it will first appear on chain, then on marketplace, where most users are. So it's pretty late for many of the users to know when the metadata for NFT are decided. But then for some powerful users, they could really just know that first because they have the ability to inspect all the on-chain transactions. That also including the transactions that are not confirmed yet, which are in the mempool. So they have the ability to just exploit all this metadata first before anyone else. Lastly, it comes to randomness. It's also critical to some of the NFT because they really want to have a bit more game concept in this so that people can just get randomized NFT from the blockchain directly. But actually on-chain, you don't really have some good random sources because it's not reliable and it's often unacceptable. So many relies on off-chain randomness oracles. But again, oracles are also vulnerable to MEV. So if you build your NFT with some oracles, you have to be careful with that. If you use it wrongly, then you introduce MEV to the system. So let's also look at the issues in governance. When you look at governance, you might think about what kind of governance you would like to have. So actually, there are two major types. One is on-chain, one is off-chain. On-chain, I think the best example here is actually the Polkadot governance or Kusama governance. They run everything on-chain, and they have a very complex system to actually handle proposals and everything. And of course, it offers some very good properties, like it's very strong. The security is very strong, because you can't just forge the votes or just do anything messy to it. And also, it comes with high cost, because every single vote is executed on-chain, so the voters have to pay the fee. And of course, it has full transparency because everyone can see the records on-chain. But also downside is it's often single chain because it's one system, so you have to just deal with it on one chain. But then if you look at the off-chain governance, you will have more flexibility, but it comes with a price, of course. It often comes with a weaker security guarantee because you will have to rely on some off-chain operator to process your votes. Although you can still sign the votes with private key, making sure the making sure the votes are legitimate, but still it's a weaker security because the operator can just do censorship. And also it's suitable for soft governance because it's not as strong as the on-chain governance. So usually people use this to do signaling or polling to just get some opinions from community first before they really run into the on-chain governance. And then, most important, it's free, because all the processing off-chain is just free. You don't need to pay anything to just get it executed. And also, a good thing is multi-chain, because with this off-chain system, you can just support as many networks as you want. We will also look into that later on. Then other challenges in governance, which is also I just mentioned, multi-chain, because now we are living a multi-chain era, and your projects maybe just run on different networks, and your tokens are also scattered around different networks, maybe in different forms. For example, you have your native token, you maybe also have a ERC20 version, and then the token is bridged to different networks with all these wrapped token symbols. And then maybe you also have these liquidity pool tokens in AMM. And all these tokens represents actually the right of voting. So as a project owner, a developer, you should really just consider them fairly, giving them the ability to vote on your proposals. Lastly, it's about voter privacy. I know that we are already used to public voting, public governance, but private voting is as important as public voting because it offers some fairness. For example, independent voting without influencing other people or without getting influenced by others. And also, it can avoid massive vote buying because if you can't prove that you have voted, then other people can't just purchase the votes from you because there's no way to prove to them. So then this is the last category about security, and it's also something really new. First thing is about 2FA or two-factor authentication. This is, again, not something new in crypto, in software, because we're using it every day on some of the internet services, but then it's really not yet possible in crypto. Because the way 2FA working is that you have a shared secret with this server, But then you couldn't just offload the secret to public chains because it will just expose your 2FA code. And it's just basically just last line of defense for your assets. If your private key is compromised, but if you're holding a separate device with 2FA code, you are probably safe because you can still rescue your assets into a different account. Maybe people think that nowadays we can use multisig as a workaround for 2FA. It's indeed 2FA, but it's mostly for pro users. I don't think average users know the best practices to run multisig. Maybe they will accidentally just put their 2 private keys or more private keys in one device and then got them compromised at the same time. So it's not that easy to use. Also, phishing attacks. We've heard news. Phishing attacks result in loss of NFTs and other assets. So what happens is the attacker will just create some website that are pretending to be the legitimate ones and then trick users into signing some malicious transactions. And what happens underneath is the transaction will just directly transfer the assets into hacker's account. But developers actually couldn't do anything about it because they don't own the infrastructure. The API endpoint they are talking to is controlled by others. So there's no way to convince them or contact them to just do origin checks for them. Although this origin check is very common in internet because it's there already. You have this origin header in HTTP. Basically, it will just record the source of the request. So if a victim visiting an attacker website and generates a request, the server could just detect it because it knows that it's coming from the malicious website. But then in blockchain context, there's no one actually doing the check for other people. Because first, it's a permissionless system. Everyone can run a full node, can run an endpoint. So it's hard to reach out to the right person to do that. Also, it's up to users to decide which endpoint they want to use when they are using the wallet. So there's really no way or system to just to coordinate on this. And it's just not so good so far. But I think we can get you covered with some of the middlewares that we are building. So maybe we can take a look at what is middleware first. So it's actually just some software glue that creates some common and reusable functions. And it can be glued together to provide more complex functions to accomplish some tasks. And there's a pretty good example in web server. When you are building web server, you often have a bunch of middleware functions which are chained together. For example, firewall, logging, authentication, and maybe metrics. So this is, again, some existing technology. But when it comes to the Web3, it's similar, but it also has some difference. So let's look at the interaction between users with blockchain system, with multi-chain blockchain system. It often comes with just 2 types of interaction. One is just writing something to the blockchain. The other one is just reading data from the chain. And about the writing is actually asking user to authorize the transaction so that it will eventually change the state on the public chain. And then reading is really simple because it's just permissionless. Everyone can read data from public chain without signing your user in. So what we're doing here is we are actually providing some on-the-fly and plug-and-play functions to just enhance your middlewares. So let's look at the the first type of middleware we have built. It's called Conveyor. It's used to minimize MEV, and it works across many chains. So what it does is it's really just a meta transaction layer, but it's not just single one. It's a replica of them. It's a bunch of them. And what it does is user just signs their transactions in the meta transaction format, which is just a payload, not the transaction themselves. But then this payload is handed over to the middleware. And middleware will start doing the on-the-fly computations, including relaying, sorting, or maybe some erasing as well, just to remove the sensitive information. Afterward, it will send to the target blockchain or the target smart contract to process it. And through this entire process, it will provide the ability of, first, gasless trading, because now the gas fee is paid by the middleware, not by users. So user can truly enjoy the gasless trading or gasless experience. without paying the native token, without paying the fee in native token. Second good thing is it's actually called fair ordering, although it's quoted, because we think the definition for fairness is different for many people. Maybe we can have all kinds of different definitions, but maybe you can go for the standard one, like the first come first serve. So we can have that. But if you want some other styles, we can also do that, because you can run any kinds of algorithm in the middleware to just sort your transactions. And second middleware we have built is called Witness. It's for multi-chain governance with privacy. By multi-chain, what we really want to say is actually a borderless governance, because it allows us to connect to multi-chain, read all your voters or holders' balance information, whether it's ERC20 token, native token, or even NFT, we can all just do that. And then we will just take the signature, take the voted side votes from users to process it. And during the processing, we will try to have some privacy, of course. Of course, we can also do public voting. That means we will just process a vote and publish to the on-chain or somewhere else. But if we want the private voting part, what we can do is we will just remove the voter identity. We will tally the vote in the middleware and then present the result directly, so that users don't have to worry about their privacy anymore. So throughout the journey of building the middlewares, we actually come up with several important properties that we think that we should have in the future as well. First thing is we are building at application level. That really means we are able to talk to any chain, and the interface that we're talking to is via their API endpoints. So it's not bounded to a particular chain. We can just have freedom to work with any chain. And also, it must provide some improved user experience. For example, the Conveyor middleware, we're providing gasless trading. We're providing fair ordering. And then from the Witness, we can have privacy. We can have multi-chain governance as well. So these are really improved user experience compared to the past. And thirdly, it has this fail-safe property, which means even the middleware fail, it will not impact the blockchain. It will not impact the application, because what middleware offer is just a highway. So if the highway is closed, you can still go through some normal routes to access your application. So that shouldn't be an issue. So maybe that's enough for just technical stuff. We should just look at some examples. Like we actually built a few first-party applications to just showcase the ability of the middleware. The first thing we built is actually called NFT Fair. It's a NFT fair launch platform, which allows projects to launch their NFT in different manners. For example, they can do fair drop. Fair drop is actually just fair airdrop. All the NFT claim transactions are ordered fairly, so that no one can actually front run others. And then we also have another style, which is mystery box sale. What it does is it allows users to just mint randomized NFT from single transactions. And they don't have to rely on Oracle to do that, because our middleware is able to provide hardware-based randomness, so that all the minting and this random source is carried in one transaction, and it can be done just easily. And also we have this fair liquidity protocol. It's called Zeta. It's a DEX with built-in MEV protection. It's just the user experience on this is quite similar to the existing DEX, with two other benefits. Like user can just enjoy gasless trading. If you trade USDT with another token, you will be likely just pay in USDT instead of paying ETH or other tokens. And we can also look at the third one, which is something we built for governance. It's using our Witness middleware, so that it can provide borderless governance along with the privacy. And this privacy, you can have different tiers, like the most strict one, maybe it's fully private, or you can just use the public voting, similar to other off-chain governance. Yeah, so I guess that's basically everything I'd like to share. So maybe a little bit recap. So I actually went over a few challenges for Web3 developers, and I went over the middleware that we have built, also our first-party application that demonstrate how middleware can be integrated. But our vision is actually still just trying to help the other developers, other the apps, that are running on different chains to really enjoy a better Web3 and provide better user experience to their users. Yeah, I guess this is just the end of the talk. We still have some time. Feel free to ask questions. Anyone? Yeah. Can you louder? Be louder? So you're asking if gasless can be used on bridging as well, right? Yeah, it's possible. So if we work with other bridges, we could just integrate the middleware. We can just take part of the functions and integrate with them so that on the bridge, you can just do gasless bridging. Anyone else? Yeah, please.
What other mechanisms are there to not abuse the middleware, like in case of gasless transactions, like how can you avoid?
Okay, I guess you're asking what kind of ordering mechanism we are using, right? So what we do is we really just take advantage of the relayers. Because in relayer, you will have this concept of local transaction queue. Because each sender of the relayer will have a non-spaced queue, which is not compromisable by the miner because they can't override the ordering of the nonce. So we make use of that, and then we just patch it together with some of the, like maybe a liquidity pool on AMM. So then all the transactions towards this pool is ordered by the relayer, by the nonce. So it's by right, it's according to the kind of the basic law of the blockchain. So no one can change it. And also, there's no one can manipulate the gas as well. Maybe one more? Anyone else want to ask? Okay, I guess that's just everything. Yeah, thanks everyone. Thanks for your attention.